What is a thermostat and how does it work? A thermostat is a device used to regulate and control the temperature of an environment, such as a room or a heating/cooling system. It is commonly used in homes, offices, and various other settings to maintain a desired temperature level by turning on or off heating or cooling devices. Here's how a basic thermostat works. Temperature sensing is a fundamental aspect of how thermostats work. It involves the use of various sensors or components to measure the temperature of an environment accurately. The information gathered from temperature sensing is crucial for the thermostat to make decisions about whether to activate heating or cooling systems in order to maintain the desired temperature. There are several types of temperature sensors commonly used in thermostats. Bimetallic strip. This is a simple mechanical temperature sensor made from two different metal strips bonded together. As temperature changes, the two metals expand or contract at different rates, causing the strip to bend. This bending motion can be used to trigger a switch that controls the heating or cooling system. Thermistor. A thermistor is a type of resistor whose resistance changes with temperature. When the temperature changes, the resistance of the thermistor changes accordingly. This change in resistance can be measured and used to determine the temperature. Bimetallic coil. Similar to a bimetallic strip, this sensor consists of a coil made from two different metals. As temperature changes, the coil expands or contracts, causing mechanical movement that triggers the thermostat's control mechanism. Resistance temperature detector. RTDs use the principle that the electrical resistance of certain materials changes predictably with temperature. These sensors provide accurate temperature measurements but are often used in more industrial or specialized applications. Infrared (IR) sensors. These sensors detect the infrared radiation emitted by objects to determine their temperature. IR sensors are used in some advanced thermostats to provide non-contact temperature measurements. Digital sensors. Modern digital thermostats often use integrated circuit temperature sensors, such as the DS18B20, which provide accurate and digital temperature readings that can be directly processed by the thermostat's microcontroller. The choice of temperature sensor depends on factors like accuracy, response time, cost, and the specific requirements of the thermostat. Once the sensor measures the current temperature, the thermostat compares it to the desired setpoint temperature to determine whether to activate heating or cooling mechanisms to achieve and maintain the desired temperature level. The setpoint in the context of a thermostat refers to the desired temperature that you, as the user, want to maintain in the environment being controlled by the thermostat. It's the target temperature at which you feel comfortable and which the thermostat aims to achieve by regulating the heating or cooling systems. Here's how the setpoint works. User input. You manually set the desired temperature on the thermostat. This is the temperature at which you want the room or environment to be maintained. Reference temperature. The setpoint becomes the reference temperature that the thermostat uses to compare against the current temperature of the environment. Comparison. The thermostat's temperature sensor continuously measures the current temperature of the room or space. It then compares this measured temperature to the setpoint you've specified. Control logic. Based on the comparison between the current temperature and the setpoint, the thermostat's control logic determines whether the heating or cooling systems should be activated or turned off. Adjustments. If the current temperature is lower than the setpoint for heating or higher than the setpoint for cooling, the thermostat will activate the appropriate system to bring the temperature closer to the setpoint. Once the temperature reaches the setpoint, the thermostat will maintain it by regulating the heating or cooling system accordingly. The setpoint is essentially the temperature goal that guides the thermostat's actions. It's the temperature you consider comfortable and want to maintain, ensuring that you neither feel too cold nor too hot. Some thermostats allow you to set different setpoints for different times of the day, programmable thermostats, or learn your preferences over time, smart thermostats, to provide optimal comfort and energy efficiency. A thermostat comparison refers to the process of comparing the current temperature of the environment, as detected by the thermostat's temperature sensor, with the desired setpoint temperature that you have specified. This comparison forms the basis for the thermostat's decision-making on whether to activate heating or cooling systems in order to achieve and maintain the desired temperature. Here's how the comparison process works. Current temperature measurement. The thermostat's temperature sensor continuously measures the current temperature of the room or space it is controlling. Setpoint temperature. You have previously set a desired temperature on the thermostat, known as the setpoint. This is the temperature you want to maintain in the environment. Comparing current temperature and setpoint. The thermostat's control logic compares the current temperature reading from the sensor with the setpoint temperature you've established. Determining heating or cooling needs, based on the comparison. If the current temperature is lower than the setpoint, indicating that the environment is colder than desired, the thermostat determines that heating is required to raise the temperature. If the current temperature is higher than the setpoint, indicating that the environment is warmer than desired, the thermostat concludes that cooling is needed to lower the temperature. Control action. Depending on whether heating or cooling is needed, the thermostat sends signals to the heating or cooling system to activate or deactivate as necessary. This action is taken to adjust the temperature and bring it closer to the desired setpoint. Continuous monitoring. The thermostat continuously monitors the temperature and makes ongoing adjustments to the heating or cooling systems as needed to maintain the temperature at or near the setpoint. The comparison process is a fundamental aspect of thermostat operation, allowing the device to respond to changes in temperature and take appropriate actions to ensure comfort and energy efficiency. It forms the basis for the feedback loop that keeps the environment's temperature regulated according to your preferences. Decision and action refer to the logical process that a thermostat follows after comparing the current temperature of the environment with the desired setpoint temperature. This process involves making a determination about whether to activate or deactivate heating or cooling systems based on the temperature comparison. Here's how the decision and action process works. Temperature comparison. The thermostat's temperature sensor measures the current temperature of the room or space. Setpoint temperature. You have set a desired temperature on the thermostat, known as the setpoint. This is the temperature you want to achieve and maintain. Comparison. The thermostat compares the current temperature to the setpoint temperature. Decision making. If the current temperature is lower than the setpoint. Decision. The thermostat determines that the environment is too cold. Action. The thermostat initiates a heating action, sending signals to the heating system to start generating heat and raise the temperature. If the current temperature is higher than the setpoint. Decision. The thermostat concludes that the environment is too warm. Action. The thermostat triggers a cooling action, instructing the cooling system to activate and lower the temperature. Control action. The thermostat sends signals to the relevant heating or cooling system to turn it on or off, depending on the decision made in step 4. This action is aimed at adjusting the temperature and bringing it closer to the desired setpoint. Ongoing monitoring. After initiating the appropriate action, the thermostat continues to monitor the temperature. It ensures that the heating or cooling system remains active until the temperature approaches the setpoint. Once the temperature is near the setpoint, the thermostat adjusts the systems to maintain the desired temperature. Feedback loop. The process of temperature sensing, comparison, decision-making, and action is repeated in a continuous loop. The thermostat continually evaluates the temperature and adjusts the heating or cooling systems as needed to keep the environment as close to the setpoint as possible. The decision and action process is at the core of a thermostat's functionality, allowing it to regulate the temperature effectively and provide comfort while optimizing energy usage. Control output in the context of a thermostat refers to the signals or commands that the thermostat generates to control the operation of heating or cooling systems. These control outputs are based on the thermostat's internal logic, temperature comparisons, and user set preferences. Here's how control output works. Temperature comparison. The thermostat continuously compares the current temperature of the environment with the desired setpoint temperature. Decision making. Based on the temperature comparison, the thermostat's control logic determines whether the environment needs heating or cooling to reach and maintain the desired temperature. Control output generation. Once the decision is made, the thermostat generates control outputs to adjust the operation of the heating or cooling system accordingly. Heating control output. If heating is needed, current temperature is lower than the set point, the thermostat generates a control output to activate the heating system. The control output could be an electrical signal that turns on a furnace, a heat pump, or an electric heater. This signal energizes the heating system, causing it to generate heat and warm the environment. Cooling control output. If cooling is needed, current temperature is higher than the set point, the thermostat generates a control output to activate the cooling system. The control output might involve turning on an air conditioner or a heat pump's cooling mode. This signal prompts the cooling system to remove heat from the environment, cooling it down. Maintaining temperature. The thermostat continually monitors the temperature and adjusts the control output as needed to maintain the temperature close to the set point. Once the temperature approaches the set point, the thermostat may reduce or deactivate the control output to prevent overshooting the desired temperature. Feedback loop. The control output process is part of a continuous feedback loop. The thermostat repeatedly assesses the temperature, generates control outputs, and fine-tunes the operation of the heating or cooling system to achieve a balance between comfort and energy efficiency. Modern thermostats, especially digital and smart thermostats, can provide more precise control outputs and offer additional features such as scheduling, learning algorithms, remote control, and integration with home automation systems. These advancements contribute to greater comfort and energy savings. A feedback loop, in the context of a thermostat and temperature regulation, refers to a continuous cycle of monitoring, comparing, and adjusting that the thermostat employs to maintain a stable and desired temperature in an environment. This loop ensures that any deviations from the set point temperature are promptly corrected, leading to consistent and comfortable conditions. Here's how the feedback loop works within a thermostat. Temperature sensing. The thermostat's temperature sensor continuously measures the current temperature of the environment. Set point comparison. The measured temperature is compared to the set point temperature that you've established as the desired comfort level. Decision making. Based on the comparison between the measured temperature and the set point, the thermostat determines whether the heating or cooling systems need to be activated to adjust the temperature. Control output. The thermostat generates control outputs to activate or deactivate the heating or cooling systems as needed. This action aims to bring the temperature closer to the set point. Adjustment. The heating or cooling systems respond to the control output, either generating heat to warm the environment or removing heat to cool it down. Temperature change. As the heating or cooling systems operate, the temperature of the environment changes accordingly. Ongoing monitoring. The thermostat continues to monitor the temperature, even after the heating or cooling system has been activated. Temperature reassessment. The thermostat periodically compares the updated temperature with the set point temperature. Adjustment continues. If the temperature deviates from the set point, the thermostat generates new control outputs to further adjust the heating or cooling systems. The goal is to maintain the temperature as close to the set point as possible. Steady state. The feedback loop continues indefinitely, with the thermostat continually fine-tuning the heating or cooling systems to ensure the environment's temperature remains comfortable and aligned with the set point. This feedback loop is the fundamental mechanism that allows a thermostat to maintain a consistent temperature in a space. It ensures that any variations from the desired temperature are detected and corrected in a continuous cycle, providing both comfort and energy efficiency. Additionally, modern thermostats, especially smart thermostats, may incorporate learning algorithms and advanced control strategies that enhance the effectiveness of the feedback loop and optimize temperature regulation over time. Modern thermostats, especially digital and smart thermostats, can offer more advanced features such as programmable schedules, remote control through mobile apps, learning capabilities. Smart thermostats learn your preferences over time, and integration with home automation systems. In essence, a thermostat maintains a balance between the desired temperature and the actual temperature by controlling heating and cooling systems to ensure comfort and energy efficiency.